Okay, so this is the practice test for chapter 1 for geometry. Okay, number 1, there's a breakfast menu that has 2 flat rectangular sections. So in 1A, we're supposed to name the intersection of plane ABF and plane CDE. Alright, so a plane is just a flat surface, so we have to find the first one for ABF. We need to find which flat surface it's talking about. So here's A, B, and F. So the whole flat surface is this left side of the menu. Plane CDE is here. So here's C, D, and E. So that's the right side of the menu. And they asked us for the intersection, the area where they intersect, or the spot or the object where they connect or overlap. And so you can see that the part that they share is this segment right here, CF, I'm sorry. So CF is the intersection there. And I'm going to go with a line segment because they stop there. You could write just a line, CF, that'd be okay too, but I'm going to go with line segment. 1B asks for you the intersection of plane CDE and AF. So again, CDE is this right side of the menu, and AF is down here. So AF is this line segment. So where they intersect, where this right side intersects with that line, is at this point F. Alright. Part C is I'm supposed to name 3 different planes that contain point C. So there's plane BCF, which is on the left. There's plane CDE, which is on the right. And there's also the secret hidden plane. I can go with like BCD. So it's this one right here, right there. 1D, name a line that does not intersect plane CDE. Oh, I need a line that's not on this plane at all. So I'm going to go with AB. Line AB does not intersect this plane at all. So in part E, I'm supposed to classify the angle BCD when the menu is unfolded and laid flat on the table. So when it's flat on the table, the menu is just going to look like this. And this is BCD. Well, if it's flat on the table, I'm going to have a flat, straight angle. So that's what this is, a straight angle. F. So in the diagram, AF is equal to FE. So AF is 9. This should also be 9. And AB is 12, and that equals ED, so that's 12 also. And since these are rectangles, this should be 9 and 9 as well. So I'm supposed to describe 2 methods to find the area of the whole thing. So, well, one method is to find the area on the left and add it to the area on the right. So to find the area on the left, it's 12 times 9, or base times height, and that's 108. But there's 2 of them. There's 2 108s. There's 2 rectangles. So I'll go ahead and multiply that by 2, and I'll go get 216 inches squared. So that's one way to do it. The other way is back to this idea of it being in like a completely flat shape. So if this was 12 and this is 9 and 9, that would be 18. So instead of doing all this work, I could have done 12 times 18. That also gets you 216 inches squared. Whichever way you like it is alright by me. Okay. And number 6, the Winter Olympics were held in Sochi, Russia, which is over here. The distance between Washington and Rome, here, is about 4,480 miles. So this is 4,480, the distance between Washington and Sochi. So this whole length right here is 5,500 miles. What's the distance between Rome and Sochi? Well, so the whole length is 5,500. This length is 4,480. So whatever this length is plus the 4,480 should equal 5,500. So in essence, to find this much, I need to take 5,500 and subtract 4,480 from it. Let me grab a calculator real quick. So 5,500 minus 4,480 is 1,020 miles. Number 2, the endpoints of J and K are given. I'm supposed to find the coordinates of the midpoint. Well, I need to make sure I know the midpoint formula. So to find the midpoint, you take the average of the x's, meaning you add x, the first x and the second x together and divide by 2. And you take the average of the y's, meaning you add the first y and the second y and divide by 2. Okay, so the first x is -3, the second x is 9, and we're going to add that and divide by 2. The first y is 2, the second y is 2, we add that and divide by 2. Okay. So -3 plus 9 is a +6 divided by 2, and 2 plus 2 is 4 divided by 2. And so 6 divided by 2 is 3, 4 divided by 2 is 2. Number 3 says we should find the length of JK using the distance formula. So here's the distance formula. Big old giant square root. Quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Now the difference in number 2 and number 3 is in number 2 we're actually finding the midpoint, which means finding the exact middle between these two spots. And in number 3 we're finding the total length between those two spots, how far the two spots are from each other. Okay. So x2 is 9 minus from the formula x1 is -3 squared, y2 is 2, y1 is 2 squared. So 9 minus -3 is 9 plus 3, so 12 squared. 2 minus 2 is 0 squared. 12 squared is 144, 0 squared is 0, so 144 plus 0 is 144, and the square root of 144 is 12. So the distance between those 2 points is 12 units. Another difference between midpoint and distance. Midpoint is an actual point, so your answer is a coordinate. Distance is a length, so your answer should be in units, inches, or whatever like that. Your answer is a length. 3b, m is the midpoint of one, and a is the endpoint of another. We're supposed to find the other endpoints. So it's not like number 2. Number 2 says these are the endpoints. I'm supposed to find the middle. So, here's J somewhere and here's K somewhere. And I'm supposed to find the middle midpoint. 3b is saying, here's A, here's M somewhere. I need to find where B is, and I don't know where it is at. So you kind of work your way backwards. In the midpoint formula, you add the x's together, or add the coordinates together, and then divide by 2. So I'm going to reverse that. I'm going to start with the midpoint. So the reverse of dividing by 2 is multiplying by 2. So I'm going to multiply that by 2. That gives me the coordinate of 4, 10. And the reverse of adding all the x's together and adding all the y's together is subtracting them. So I'm going to double, because that's the reverse of dividing by 2, and subtract. That's the reverse of adding. And I'll subtract the original point, A, one of the endpoints. 4 minus 2 is 2. 10 minus 3 is 7. So B, the endpoint is at 2, 7. You can kind of see that there. A is at 2, 3. M is at 2, 5. So it's 2 units just strictly straight up from A. So 2 units more would be 2, 7. That's where B is. Number 4, I need to identify the bisector of ST and then find ST. ST is this line segment here. Well, a couple things could be a bisector. A bisector means something that cuts the segment into 2 equal parts. Well, the bisector could be this point M, because that divides this segment into 2 equal parts. You can see they're equal because of these marks. So M could be the bisector, or this line L could also be the bisector. You can see it's going through and cutting that segment right in half. Okay, so that's what a bisector is: cut something in half or in 2 equal parts. Find ST, meaning find the distance from S to T. I need to find this whole distance. These markings mean that these 2 segments are equal. SM is equal to MT, and SM is 3x minus 6, MT is x plus 8. They are equal to each other because that segment got bisected. Let's solve this. We're going to subtract x from both sides. Now we're going to add 6, and I get that x is 7. I make sure and read the directions, make sure if I'm done or not. It says find ST. I have not found ST, I just have x is 7. To get ST, I need to make sure I plug this x value into these expressions. So 3x, 3 times 7 minus 6, that's 21 minus 6, that's 15. So this length is 15. I can either plug this in or know that since these are equal, that this is automatically 15. So the length from S to T all the way across is 15 plus 15, or 30 units. Okay, so number 5, there's a house, and then there's a fence. So I'm asked to find the perimeter of the fence around the house and the area of the lot it encircles. Let's start with perimeter. Perimeter is how far are the distance around a shape. So here's my shape. Luckily, this shape is a rectangle. There's no diagonal length, so I can just count my lengths to the left and right and up and down. So that's 1, 2, 3, 4, 5, 6 units there. So that means since it's a rectangle, it's also 6 at the top. And counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units there. I mean, it's 12 also over here. So since perimeter is adding all the way around, 6 plus 6 plus 12 plus 12, that's 36 units around. Now area for a rectangle is base times height. Ooh, not that, sorry. My base is 6. My height is 12. 6 times 12 is 72. And that's in units square, square units there for area. Number 6, I'm supposed to name 3 different angles in the diagram. Okay, so let's start with this one. That's angle PQR. You have to make sure that the vertex is in the middle of the 3 letters that you have. A lot of people try to just name this as angle Q. That's not good because I don't know which one you're talking about when you say angle Q. So we need 3 letters there. So RQS is another one. And the whole thing, PQS, is another one. Name a few wrong angles too. Well, I told you angle Q is incorrect. Well, maybe like angle PRQ is incorrect because that's not the angle. That's not this one. So that's that. And maybe if, I don't know, if I said SQP, it's technically this angle, but I have already said PQS. Those are the same things. So maybe you shouldn't be naming them the same one twice. Okay. So that's 7. B is the complement of A. A is 65.2 degrees. Find the measure of angle B. So sketch a diagram. Complement means to add up to sum up to 90 degrees. So they need to make a right angle somehow. So I'm drawing a bad thing. So angle A is 65.2 degrees. That's probably not way bigger than 65.2 degrees, but that's fine. But to be a complement, you need to add up to equal 90 degrees. So to find the complement, I'm going to take 65.2 and subtract it from 90. That's 24.8. The problem can change if I asked you to find, or if you were asked to find the supplement. So remember that complementary angles add up to equal 90 degrees. Supplementary add up to equal 180. So make sure you know the difference. If the problem was supplementary, I take 180 and subtract 65.2 from it. Okay. Number 8, I'm supposed to name all the polygons according to the number of size, up to 12, and then to find convex versus concave. Well, I'll do this first. Convex is where it's just like a normal looking shape, like this. Concave is where kind of the shape goes in on itself. So one of my students said it looks like a cave there. So yeah, that's concave. That's where the cave is. The names of the polygons from 1 to 12. 1, there's no such thing as a one-sided polygon. 2, there's no such thing as a two-sided polygon. 3 is a triangle. 4 is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a septagon or heptagon, I think your book uses. 8 is octagon. 9 is a nonagon. 10 is a decagon. 11 is actually unnamed, it's an 11gon. And 12 is a dodecagon. Number 9, it says construct a segment bisector. That means I need to take a segment and cut it in half. And an angle bisector, which means I need to take an angle and cut it in half. So let's start with the segment bisector. Here's AB. I need to bisect that. I need to cut that in half. So I take my compass, put the sharp point at one of my endpoints. I make sure I open my compass to more than half the length of the segment. This is really right on the nose, about half, so I want to make sure, so I'm going to open up a little bit more. Then I do this giant sweeping half circle. Okay, I keep my compass open to that same amount, and then I flip it around and do another giant sweeping half circle. Notice how the half circles intersect above and below your line segments. We need to get those points of intersection and connect them. So this line right here, this line, I can call it this line, is the segment bisector. It cut that segment into two equal pieces. An angle bisector cuts an angle into two equal pieces, or half. So let me just start by making just random angle. So let's call this angle C. So I need to bisect this angle C. So first step is to take the sharp end of your compass and place it on the vertex and make an arc through both legs of your angle. Make sure it intersects the angle in two parts, just there and there. Take those two intersection points and open up your compass and make an arc on the inside of the angle. Keep your compass open to that amount. Go to the point of intersection at the bottom and make that same arc. Again, notice how arcs intersect there. I need to take that and connect it to my vertex C. This ray right here is an angle bisector. That's the object that's cutting the angle into two equal parts. Number 10 says line AB is 37, and just use the figure to find the following: X, BC, and AC. Now, this is kind of a tricky problem. Usually, they give you the total up here. They usually give you the whole length. So a lot of students will think, oh, all the way across here is 37. Not true. Make sure you read the problem. It says AB is equal to 37. Just this length right here is 37. So what has to be true is that this 2x minus 1 has to equal that 37. So let's add 1 to both sides. And divide by 2. So I need to do 38 divided by 2, and that's 19. So x is equal to 19. They want me to use that to figure out what BC is. Well, BC is 9x plus 3, so I can take 9 times 19 and add 3 to it. So 9 times 19 plus 3 is 174. Units. Then they want AC, which means the whole length. Well, I already know that AB is 37 and BC is 174 using the segment addition postulate, like these two segments. I can add them up and get the whole thing. So 37 plus 174 is 211 units. In number 11, I'm supposed to find the measure of angle QRS. So I'll highlight that there. They told me that PRS is 98 degrees. So this whole thing is 98 degrees. Well, since I know this whole angle is 98 degrees, and this is 3x minus 8, and that's 2x plus 6, I know I can take these smaller angles, add them up, and they should equal the total angle, and the total angle is 98 degrees. So using the angle addition postulate, I'm adding these two angles together to give me that. So I'm going to combine like terms, since all these terms are on the same side of the equal sign. 3x and 2x make 5x. Negative 8 and positive 6 make negative 2. Add 2 to both sides. That equals 100. Divide by 5, and x is 20. Again, I check to see if I'm done, or if that's what the directions asked. They didn't. They asked me to find that angle. So I need to take the 20 and substitute it back in. 2 times 20 plus 6 is 46 degrees. So angle QRS is 46 degrees. And in number 12, I'm supposed to use a protractor to draw a right angle, an acute angle, and an obtuse angle. So I need a protractor. So a right angle is an angle that's exactly 90 degrees. An acute angle is an angle that's less than 90 degrees but bigger than 0. And an obtuse angle is an angle bigger than 90 degrees but smaller than 180. So here's my protractor. I'm going to start with a ray for the right angle. Here's my ray. This is my endpoint. Put the bullseye on the ray, on the vertex or the endpoint of the ray, and then I make sure it's lined up so that this ray is lined up to 0 right there. There's the mark for 90 degrees. I'm going to put a dot, and I'll line that up and connect that. Or I don't actually have to connect it all the way. That's a 90-degree angle right there. An acute angle, I don't really need to use a protractor to make. I know that it's got to be less than 90, so there. That's acute. And obtuse, I don't actually need a protractor, I just need straight edges. I need to know that it's more than 90 and less than 180, so that's obtuse.